In this chapter, we will discuss various forms of energy and energy transfer by heat. We will introduce various forms of work and discuss energy transfer by work. We will continue the discussion with developing a general intuitive expression for the first law of thermodynamics, also known as the conservation of energy principle, which is one of the most fundamental principles of nature. And we then will demonstrate how it is used. Finally, we will discuss the efficiencies of some familiar energy conversion processes and examine the impact on energy conversion on the environment. We are familiar with the conservation of energy principle, which is an expression of the first law of thermodynamics. We are told repeatedly that energy cannot be created or destroyed during a process. It can only change from one form to the other. This seems simple enough, but let's test ourselves to see how well we understand and truly believe in this principle. Consider a room whose door and windows are tightly closed and whose walls are well insulated so that heat loss or gain through the walls is negligible. Now, let's place a refrigerator in the middle of the room with its door open and plug it into a wall outlet. You may even use a small fan to circulate the air in order to maintain temperature uniformly in the room. Now, what do you think will happen to the average temperature of the air in the room? Will it be increasing or decreasing? Or will it remain constant? A heated discussion may continue with no end in sight until we remember the conservation of energy principle that we take for granted. If we take the entire room, including the air and the refrigerator as the system, which is an adiabatic closed system, since the room is well sealed and well insulated, the only energy interaction involved in the is actually the electrical energy crossing the system boundary and entering the room. The conservation of energy requires the energy content of the room to increase by an amount equal to the amount of electrical energy drawn by the refrigerator, which can be measured by an ordinary electric meter. The refrigerator or its motor does not store this energy. Therefore, this energy must now be in the room and it will manifest itself as a rise in the air temperature.